Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Abudiwa Sos Ugobela Wemet. And in today's lesson, we're going to be looking at momentum and impulse. We are using a document here on technical sciences. You know, those self-study documents that they give you. So we're just going to be doing a couple of questions from this document here, starting all the way from question number 1. So let's scroll to that. Okay. Now here we go. We have exercises, and then let's just exercise a bit. Okay. It says question 1, to improve the safety of motorists, modern cars are built so that the front end crumbles upon impact. A 1,200 kg car is traveling at a constant velocity of 8 meters per second. It hits a wall and comes to a... It says question 1, to improve the safety of motorists, modern cars are built so that the front end crumbles upon impact. A 1,200 kg car is traveling at a constant velocity of 8 meters per second. It hits a wall and comes to a complete stop, right? So read that it comes to a complete stop, meaning that at this point, the velocity is equals to 0. Now, number 1 here says calculate the change in momentum. So quickly on that, we just go change in P, that's M, VF minus VI. And then what is our mass? That's 1,200 kg. Our final velocity, it comes to a stop, so it needs to be 0. Then our initial velocity has to be this one here, 8, right? And then when we multiply all that, this gives us negative 9,600 kg meters per second. But then remember, in physical sciences, we have to conclude on this negative. Looking at the cardinal points that they've given us here, we are given west and east. And then they indicated a positive just above east here to indicate to us that we need to take east as positive. So now that we got it as a negative, we know that it indicates that the momentum is on the western direction. So we need to say 9,600 kg meters per second west, right? So that's the meaning of that negative. Now, number 2 says calculate the average net force exerted on the car. So in order to calculate that one, we need to make use of the impulse momentum theorem, the formula here, which goes, we know that the impulse of an object is equal to its change in momentum. But then here we are using this to calculate the F net. So we can just manipulate the formula and say F net is equal to change in P over change in T, right? But if we can just look at this here, we can see that we have already calculated the change in P, guys. That's negative 9,600. So we're just going to substitute it as negative 9,600. Note that I'm not substituting it as a positive here because my magnitude, I got it as negative 9,600. The west here is just to indicate for the negative direction there. But then when I substitute the value, I substitute it as a negative, right? And then my change in time, that's 0.25. So they said all this happened over a course of 0.25 seconds. Then all you need to do is grab your calculator, say negative 9,600 divided by 0.25. That gives us negative 38,400 newtons. But then in conclusion, our F net is equals to 38,400 Newton west, right? So we know according to our Newton's second law in terms of momentum, they tell us that the rate of change in momentum should be in the same direction as the net force. So we can see that the net force is west and also our change in P is west, right? So they should always be in the same direction. Then number 3 here says, for the same impulse, determine the average net force exerted on the car if it had a rigid bumper and frame that stopped the car in 0.040 seconds, right? So all that we need to do here is apply the very same formula that we applied for number 2. So to say that we have F net is equals to change in P over change in T. But note this, for the same impulse. Using the impulse momentum theorem, we know that the change in impulse, the change in momentum meant to say of an object is equals to its impulse, right? So that means when they say for the same impulse, this is the same as saying for the same change in momentum, right? So for the same impulse is also for the same change in momentum. That means our change in momentum here, we should still substitute negative 9,600, right? Over our change in time, now it's 0.040, right? Now when we punch all this, we get negative 240,000 newtons, right? Then that is to say, whenever we decrease our change in time, what happens to the net force? The net force increases because there is an inverse relationship between our delta time and our F net. So what we want with our crumple zones here that we are building is to actually increase the change in time so that the net force that is exerted on the car is a minimal, right? If the net force is a minimal, then this actually reduces the risk of injuries, right? So always with our crumple zone, we want to increase the time, but then we'll understand that as we continue solving these questions, right? So that means our F net is 240,000 Newton, and then it's going to the west direction. So that's all that you needed to do for that. Let's proceed. Okay, so we have 1.2. It says a rubber ball with a mass of 800 gram, which already at this point we can see that it is not in the desired SI unit. What we need to do if something is given in grams is take that value divided by 1,000 and then have our mass in kilograms, right? Then they say it's dropped and hits the floor with an initial downward velocity of 6 meters per second. The ball bounces back with a final velocity of 4 meters per second. Now let's just do this in terms of our Cartesian plane. So in terms of our Cartesian plane, we know that upward is positive and downward is negative. So we're just going to take this one here because it's going down. We're just going to indicate it with a negative. And since this one here, our V final is going up, we're going to indicate it as a positive because that's how we know how from our Cartesian plane, right? Then what are we supposed to do here? We are supposed to calculate the change in momentum of the ball. So we have the formula change in P is mVF minus VI. What is our mass? That's 0.8, remember? But our final velocity, that's 4. And our initial velocity, that's negative 6. We have the negative from here. So the negative and negative will give us positive 6 here. Then if we say 0.8 multiplied by this, we get 8 kg meters per second. But since it's coming out as a positive, that means our momentum is in the upward direction. So that's 8 kg meters per second upward. And just like that, you have calculated. So you would still get the same answer, guys, even if you had assumed that you take your downward as positive and your upward as negative, you would still get 8 kg meters per second upward. The only difference is that if you had done that, you would have got the 8 as a negative because you would have assumed that the upward direction is negative, right? Then let's move to question number 2. So question number 2 says car A that has a mass of 2,000 kg is moving at 8 meters per second to the west, right? So at this point, we have deduced that west is the negative direction and east here is the positive direction. It collides with car B that has a mass of 4,000 kg moving at 1 meter per second to the east. Right. Then 2.1 says state the principle of conservation of linear momentum. We already know that one. It states that in an isolated system, the total linear momentum is conserved, or you can say it remains constant. So either way, it's correct. It states that in an isolated system, the total linear momentum is conserved, or you can say it remains constant. Right. So that in an exam situation would have given you 2 marks. Then 2.2 says calculate the change in momentum of the 2,000 kg car. So the 2,000 kg car is the blue one here. So we just go 2.2, that's change in P is equals to M VF minus VI. What is our mass? We have 2,000. And then our final velocity, look at this, it's going east. So that's 4. But then the 8, it's going to the west direction. So that's minus 8, right? So that's minus -8 minus -8. That's plus 8 at the end of the day, because it will be 4 minus -8. Negative and negative is a positive. Then 2,004 plus 8, that will give us 24,000 kg meters per second. And since now our value is a positive, that means our momentum is to the eastern direction, right? So that's 24,000 kg meters per second east. Then 2.3 says calculate the velocity of car B if car A moves with a velocity of 4 meters per second after the collision, right? So how are we supposed to do that? We have our formula here for the principle of conservation of linear momentum. So note that most of the time when they make you define that, somewhere along the questions, you will find where you need to use this. Now, looking at this situation, we can see this is a situation whereby both these objects were moving individually. Then after collision, they collide and then they still move separately, right? So initially they were moving separately, they collided and still moved separately, right? Because now they gave us the velocity for car B, but now they want us to calculate the velocity for car A. So this was supposed to say calculate the velocity of car A if car B moves with a velocity of 4 meters per second. So if you are using this document, please note that mistake there. Right. Then we have M1 V1 plus M2 V2. So the 1 will be representing car A and the 2 will be representing car B. Right. Then they still move separately after collision. So M1 V1 plus M2 V2. Then our mass for car A, 4,000. The velocity, it's 1 meter per second and to the right direction, so that's positive. Then we have 2,000 here, but then the 8 meters per second is to the left direction or the west direction, so it's -8, right? So note, one thing that can really be tricky here is having to always note your directions here. So always make sure that you are alert when it comes to that. So here we have 4,000, but then note here we do not have the velocity. That's what we are trying to calculate. So we V1 finally plus 2,000. We do have the velocity for this car here. That's 4 meters per second. And then it's going to the right, so it should be positive. And then let's just calculate that. When we punch all this in our calculator, this gives us -12,000. And then here When we multiply this, it should give us 8,000, so we can just transpose it right away. So that's minus 8,000 is equals to 4,000 VF, right? Then now at this point, what we can do is just say negative 20,000 is equals to 4,000 VF. Then if we divide both sides by this 4,000, then our VF is equals to negative 5 meters per second. And then now the negative here, we interpret it as west, 5 meters per second west. So that's our conclusion on that. Right. So correct. Let's proceed. Okay, so we have question number 3. It says a cannon has a mass of 1,250 kg. It fires a cannonball during a routine exercise. The cannon is 1,000 times heavier than the cannonball. So the cannon here, it's all this, then the cannonball is the one that is being fired there. The cannonball leaves the barrel at a horizontal velocity of 70 meters per second. Then they say, always note, guys, in these questions, most of the time, they like this trend of giving you a whole statement here, then they just give you a statement below here. Most of you guys, you just never see this statement here. And then this statement might hold some information that is valuable, but then if you just skip all the way to the questions and ended up not seeing this statement, you might find yourself wanting to calculate what is already given to you, right? So make sure that you check if they ever did this here. So make sure that you check all the statements that you need to read and highlight. Then 3.1 says define in words the term impulse. So we know how to define impulse according to its formula that goes F net multiplied by delta T. So we say the impulse. So we say impulse is the product of the net force acting on an object and the time it takes to act on the object. So that is our definition of impulse. This is the product of the net force acting on an object and the time it takes to act on the object. Hence, we have the formula F net multiplied by delta T. So this is the net force acting on an object and the time that net force takes to act on that particular object. Right. Then we have 3.2. It says calculate the following: the maximum velocity with which the cannon moves backward. So this is to tell you about Newton's third law. Remember, when we are firing this cannonball from the cannon, we are actually making the cannon to exert a force on the cannonball, which in turn the cannonball exerts the same magnitude of force, but in the opposite direction, making the cannon here to move backwards. So remember, the cannon here is firing the cannonball forward, but then because of Newton's third law, the same cannonball is exerting a force on the cannon, making it to move backward. So what we are trying to calculate here is the velocity with which the cannon moves backward. So how are we going to calculate that? We have our formula from the principle of conservation of momentum. So we have sum of PI, momentum initial, is equal to sum of momentum final. Then now I want you to understand this. Initially, the cannonball and the cannon were moving as a unit, or we can say they were a unit. They were just together stationary as a unit. So that means M1 plus M2 VI, right? So initially, the cannonball was not fired and the cannon was just stationary, meaning the cannonball also had a velocity of 0 because it was stationary with the cannon. Then, after they fired, this is what happened. The cannon moved at its own velocity, and the cannonball also moved with its own velocity. So they became separate after the firing of the cannonball. Right. Then here we have our mass number 1, which we can say is the mass of the cannon. That's 1,250. We are not given the mass of the cannonball, but then we are told that the cannon is 1,000 times heavier than the cannonball, right? So in order to find the mass of the cannonball, we can simply say 1,250 divided by 1,000, right? Since we are told that this mass here of the cannon represents 1,000 times, a mass that is 1,000 times greater than the cannonball itself, right? So in order to find the mass of the cannonball, we can just divide by that 1,000. Now we find that that's 1.25 kg, right? So 1,250 kg is 1,000 times greater than 1.25 kg. Hope that makes sense. Then plus 1.25. Then our V initially, the cannonball and the cannon were stationary. So our V initially is 0. Mass of the cannon, it's 1,250. We do not have its velocity. We do have the mass now of the cannonball and the velocity of the cannonball, which is what? 70, as we can see here. Now to calculate that, that's 0 from all that. And then we have 1,250 VI. Now, if we multiply that, that's 1.25 multiplied by 70. It gives us 87.5. Then we can just transpose negative 1,250 over to the side VI. 87.5, then divide both sides by negative 1,250, negative 1,250. Our initial velocity now becomes negative 0.07 meters per second, which in conclusion we can say, remember this, yes, this is supposed to be V1F. So this means it's 0.07 meters per second backwards. Right. So this is the maximum velocity with which the cannon moves backwards. Then, okay, 3.2.2 says magnitude of the average net force that causes the cannon to come to rest. Right. So what can we do to calculate that one? We have our formula here, which is F net is equals to change in P over change in T, right? Breaking it down, that's mass VF minus VI over change in T, right? Our mass for the cannon is 1,250, but then they're saying magnitude of the average net force that causes the cannon to come to rest. If something comes to rest, that means final velocity is 0. But then the initial velocity becomes the velocity in which it moves backwards, right? So the velocity with which the cannon moves backward now becomes our initial velocity. So we need to substitute here our negative. Remember, we had our velocity as negative 0.07. So if we are to substitute it here, that's minus and then negative 0.07, which will then give us, so over what? Over 1. Remember they said the cannon comes to rest 1 second after the cannonball was fired. So it takes 1 second for the cannon to come to rest. Now, if we punch all this in our calculator, let's go. We have 1,250, 0. We know that negative and negative is positive, so we can just say 0 plus 0.07, and then over 1. That will give us a value of 87.5 newtons, right? So that is the value that we get. That is the magnitude of the average net force that causes the cannonball to come to rest. So that's how you were supposed to just calculate that one. Now, let's proceed. Let's proceed to other questions. Okay, so we have question number 4. It says collisions happen daily on the roads in our country. In one of these collisions, a car with a mass of 1,600 kg is traveling at a speed of 30 meters per second to the left. So since it's going to the left, just going to take this one as a negative. It collides head on with a minibus that has a mass of 3,000 kg, which is traveling at 20 meters per second to the right. The two vehicles move together as a unit. Note that the two vehicles move together as a unit in a straight line after the collision. Right, then 4.1 says calculate the velocity of the two vehicles after the collision. So we can get that this is case number 2 from our collisions, whereby now we understand that the two vehicles were moving separately, but then after the collision, they move together as a unit. That means they share the final velocity. So what we need to do here is to say momentum initially is equals to sum of momentum final. So we have them individually like this. But then finally, what happens? They move together as a unit, so they share the final velocity. Right. So now, having to calculate, we have 3,000. What's our initial velocity? 20. It's going to the right. And then plus 1,600. But what's our initial velocity? That's 30, but then it's going to the left, so it needs to be negative 30. Then mass 1, 3,000. Mass number 2, 1,600. And then we are looking for VF. Now let's punch all this in our calculator. That's 3,000 multiplied by 30 plus 1,600 multiplied by negative 30. Okay, so that was 3,000 multiplied by 20. Then we have 12,000 is equals to 4,600 VF. Divide both sides by 4,600. Then our value is 2.61 meters per second, rounded off to 2 decimal places. And then where is it going? To the right. To the right. Now 4.3 here says the billboard below advertises a car from a certain manufacturer. Use your knowledge of momentum and impulse to justify how the safety features mentioned in the advertisement contribute to the safety of the passengers. So we have this advertisement here, safety first, both in one package, your airbag and your crumple zone. Then they show you before impact and after impact. So the crumple zone crumbles here, but then it never reaches the safety carriage here, which is that is to protect the passengers so that they do not get injured. Right. Now, we are supposed to use our knowledge of momentum to explain what is really happening here. So to explain that, we say during a collision, the crumple zone or the airbag increases the time during which momentum changes. During which momentum changes. Right. Then, but according to F net is equals to change in P over change in T, we know that our F net is inversely proportional to change in time. Right. So if we increase the time during which momentum changes, that means the net force during impact will decrease. And this reduces the risk of severe injuries during collisions. Right. So that's how you are supposed to explain it. During a collision, the crumple zone or the airbag increases the time during which momentum changes. According to F net is equals to change in P over change in T. F net is inversely proportional to change in time. The net force during impact will decrease, right? Remember, if we increase change in time, we must decrease the F net. So the net force during impact will decrease, and this reduces the risk of severe injuries during collisions, right? So that's how you are supposed to explain that for 3 marks there. Now let's move to question number 5. The diagram below shows two trolleys P and Q that are held together by means of a compressed spring on a flat, frictionless horizontal track. The mass of P and Q is 300 gram meant to say, and 500 gram respectively. As we can see, P 300 gram, Q 500 gram, right? Then we know that this is not in the desired SI unit, so divide that by 1,000. Then it gives us 0.3 kg. Divide that also by 1,000. It gives us 0.5 kg. Right. So now we have proper masses. When the trolley, look at this, you see they're repeating that thing with the statement below the diagram. When the trolleys are released, it takes 0.5 seconds for the spring to unwind to its natural length. Trolley Q then moves to the right at 2 meters per second. If you can look at in terms of importance or in terms of which statement has more information, you can say that the statement that is below the diagram here holds much information that will help us in terms of our calculation as compared to this. Whatever that has been written on this statement, you can clearly see on the diagram. But with this statement here below the diagram, you can see that this is some new information, some valuable information there, right? Then 5.1 says state the principle of conservation of linear momentum. Again, so write it as many times as possible so that you make sure that you don't forget it. But also take this as one of the lessons that you need to check in terms of identifying your trends in your question paper. You have seen that since we have started, this definition has been appearing, right? So this tells you that this definition has more chances to appear in your exam than any other definition when it comes to momentum and impulse. So you have to make sure that you know it. Okay, so now let's define it. It says states that in an isolated system, the total linear momentum is conserved or it remains constant. So that's how you are expected to define it, right? So write it until you know it by heart. Then 5.2, calculate the following. 5.2.1, the velocity of trolley P after the trolleys are released, right? So now how are we supposed to do that? We can see that this is a situation whereby both the trolleys were moving as a unit and then they became separated, right? So this means what are we supposed to apply here? Momentum initially. Sum of momentum initially is equal to sum of momentum finally. So here we have them sharing the same initial velocity, m1 plus m2, and then vi. Then after they separate, m1 v1 plus m2 v2, right? So we had 0.3 plus 0.5. But then initially they're just held together. That means if they're held together, they had an initial velocity of what? 0. Hence, they even say here when the trolleys are released, you only release something if you have been holding it stationary. So this tells you that your velocity is equals to 0. Now your mass here, 0.3, and then your velocity, 4p, we are not given. That's what we are looking for. Velocity of trolley P after the trolleys are released. So remember, this is before initially, and then this is after. So we are looking for this velocity here, Vf, plus our mass, 0.5. But then we are given that the velocity of trolley Q is 2 meters per second to the right. So that's positive 2. Now, if we multiply this, we're just going to end up getting 0. Then this is 0.3 Vf. Multiplying this, we have 1, right? Can take this over to the side, negative 0.3 Vf is equals to 1. Divide both sides by negative 0.3. Now our value is negative 3.33 meters per second. Then in conclusion, that means that's 3.33 meters per second. To which direction? Left. Right. So, and that's how we have it. 5.2.2 says, calculate the magnitude of the average force exerted by the spring on trolley Q. Right. So to calculate the average net force, remember we already have the formula. F net, change in P over change in T. Now at this point, you can see that we are doing one and the same thing. This is just for you to be able to identify the trend. If you want to identify the trend and see what kind of questions they ask in an exam, do about 3, 5 questions and then just see what are the questions that constantly appear there, right? Then in that way, you have identified the trend. Then for trolley Q, that's 0.5. Our VF, that's 2 meters per second, but initially it was stationary, so that's 0. And then our change in time, they say it takes 0.5 seconds for the springs to unwind to its natural length after it is released. So that's 0.5. Now, if we divide this, we are left with 2. So that's 2 newtons. Now, to which direction? It's to the right, of course. Hey, now 5.3 is asking, is this an elastic or inelastic collision? So without any calculation, we can tell that this is inelastic collision, right? Inelastic collision. So even if we were to calculate, remember, sum of EK initially, this will just give us 0 joules because remember, they're still held stationary. So there is no velocity for P, no velocity for Q. The velocity is just 0. So that's 0 joules. And then obviously a sum of EK finally would end up giving us something. So because EK initially would not be equals to sum of EK finally, then you'd say this is inelastic collusion, right? So, which is why they just asked it as a question, is this an elastic or inelastic collusion? Should tell you that it's inelastic. And if you have to go back and refer to your notes, you know that if your objects are just held stationary like this and then they are released, obviously that collusion will be inelastic, because with most of the elastic collusions, the what you call your objects are, most of the time they are objects that are separate, right? Then let's proceed. Okay, so we have question 6 here. It says the diagram below shows a bullet with a mass of 20 grams that is traveling horizontally. The bullet strikes a stationary 7 kg block and becomes embedded in it. The bullet and the block travel on a rough horizontal surface for a distance of 2 meters before coming to a stop. Now you saw some of the keywords. The 7 kg, it strikes a stationary 7 kg block and becomes embedded in it, as we can see here. So that means now we create a bullet block system whereby all this, they are moving with the same velocity. As we are told here, at the moment of impact, the bullet and the block begin to move with a velocity of 2.39 meters per second. Now 6.1 here says, state the principle of conservation of linear momentum. We will write it until we know it, right? So this is it states that in an isolated system, in an isolated system, the total linear momentum is conserved. Now at this point, you already have that formula at the back of your mind. You won't even have to, you won't forget it, and you wouldn't even have to memorize it just a day before you write your exam. Please leave that. Then 6.2 says, calculate the magnitude of the velocity with which the bullet hits the block, right? So in order to calculate that, we obviously need our formula here. Sum of momentum initially is equals to sum of momentum finally. So that's m1 v1 plus m2 v2. But then finally they become one unit, so they move together as a unit, so they share the final velocity. So what is our mass here? 20 gram, not in the desired SI unit, so we need to say 20 divided by 1000. That gives us 0.02 kg, right? Then 7 kg, that's definitely in the desired SI unit. So we can just leave it like that. Then let's calculate our mass number 1. We have 0.02. Then the velocity, are we told? We are not told. That's what we are trying to calculate. Calculate the magnitude of the velocity with which the bullet hits the block, the initial velocity of the bullet. Then mass 2, that's 7 kg. But then this is for the block. The block was just stationary. So that means the velocity is 0. We have 0.02 plus 7. And then the VF, we are told that at the moment of impact, the bullet and the block begin to move with a velocity of 2.39. So we put 2.39 here. Right. Then let's calculate. This will just give us 0. So we are left with 0.02 VI is equals to, we need to calculate that as 0.02 plus 7 multiplied by 2.39. That will give us 16.7778. Then we can divide both sides by 0.02. Then VI, we divide that by 0.02. We end up with 838 0.89 meters per second. Right. And then to which direction? It's going to the right. Right. It's going to the right. So that's how you were supposed to calculate your 6.2 there. Let's move. Now, question 7. They say a trolley with a mass of 5 kg moves at 4 meters per second east across a frictionless horizontal surface. A brick with a mass of 1.5 kg is dropped onto the trolley. Right. Now, 7.1 again, state in words the law of conservation of linear momentum. It states that in an isolated system, the total linear momentum is conserved. This is how you go about practicing, guys. This is what you do when you practice past exam papers. So 7.2 says state the condition for an elastic collision. Now, with an elastic collision, we know that the kinetic energy is conserved. We know that the kinetic energy is conserved. 7.3 says calculate the change in momentum of the 5 kg trolley. How to calculate change in momentum? So we say change in P, that's mass, Vf minus Vi, right? And then a trolley with a mass of 5 kg moves at 4 meters per second east across a frictionless horizontal surface. A brick with a mass of 1.5 kg is dropped onto the trolley. So what are we supposed to do here? Before we can calculate the change in momentum, that means we would have to find the final velocity. So that means our journey begins here. Sum of momentum initially is equals to sum of momentum final. Now we have M1. These are two objects. It's the brick that has been drawn from upward there, and then we also have our trolley M1 V1 plus M2 V2. But then I want to introduce you to a special case here. This is a special case, guys. When you have an object being thrown vertically like this, but then the object that is moving here is moving on a horizontal plane. What we'd actually consider with this one, we would consider its velocity to be 0, right? So the velocity of the brick here becomes 0 because in terms of its horizontal movement, this brick here has no horizontal velocity. It only has vertical velocity, right? So in this case, we have to assume that its velocity is just 0 because our velocity is in terms of the horizontal movement, right? So here we have mass number 1. Our mass number 1 is 1.5 kg, but our velocity is 0. Mass number 2 is 5 kg. Our velocity is 4 meters per second. Then now we know that when the brick falls into the trolley, they will now become a system. They will now move together as one unit. So that means mass 1 and mass number 2, they share the same velocity. So we have 1.5 plus 5, and then they share Vf, which is what we are looking for. Then when we calculate that, that's only 5 multiplied by 4, that's 20. Then 1.5 plus 5, that's 6.5. Then Vf, divide both sides by 6.5. We have 20 divided by 6.5. This gives us a value of 3.08 meters per second, rounded off to 2 decimal places. then where is it going? It's going to the right. But then remember, we are to calculate the change in momentum. Now we have the V final and then we have the V initial. Therefore, we can calculate the change in momentum. We have mass Vf minus Vi. The mass for the 5 kg is 5 kg. Vf 3.08 minus Vi, that's 4. Now we want to calculate here, so we can see that after the brake fell into the trolley slowed down. So that means our momentum has to be in the opposite direction. So that gives us negative 4.6 kg meters per second, which we can then conclude and say change in P is 4.6 kg meters per second. To which direction? Left, right? So because there's the slowing down of this object, that means the change in momentum is acting in the opposite direction, right? Then let's still continue. Okay, so we have question 8. It says a girl with a mass of 65 kg is driving a 535 kg snowmobile at a constant velocity of 11.5 meters per second, 60 degrees or east of north. Calculate the momentum. Calculate the what? The momentum of the girl's snowmobile system. So the first thing that we need to figure out here is the combined mass of the girl and the snowmobile. So we just go 65 plus 535. This gives us 600 kg. So the whole system is 600 kg. Now to calculate the momentum, we know the formula P, M times V. So our mass is 600 and then multiplied by our velocity of 11.5. Then that's 600 multiplied by 11.5. This gives us a value of 6,900 kg meters per second. That's all you needed to do for that one. Quite easy. Now, question 9. A boy on a skateboard moved to the right at a constant velocity. The joint mass of the boy and the skateboard is 50 kg. He catches a ball with a mass of 0.4 kg while the ball is traveling horizontally to the left. So to the left, we take it as negative. And then after the boy catches the ball, they both move to the right at 1.49 meter per second square, right? So we take that one as a positive. Now define the term impulse. We already spoke about that. We said, what is impulse? This is the product of the net force acting on an object and the time taken for the net force to act on an object, to act on the object, right? So that becomes your definition for the impulse, the product of the net force acting on an object and the time taken for the net force to act on the object, right? Then 9.2 says calculate the magnitude of the average force that the boy exerts on the ball when he catches it, if he and the ball exert a force on each other for a period of 0.1 second. Right. So what are we supposed to do with this one? To calculate our average force F net is equals to change in P over change in T. Right. So we can just go about and say M Vf minus Vi over change in T, right? So what are we trying to calculate? The average force that the boy exerts on the ball, right, when he catches it. So we can either use the mass for the boy or we can use the mass for the ball, right? So let's go ahead and use the mass for the boy here. That's mass 50. Vf the final velocity for the buoy, we can see that, okay, so we are not given the velocity of the buoy. That means we cannot use that one. Okay, pardon me for that. So we can use the mass of the ball, that's 0.4. The VF for the ball, remember, they are all moving as a unit here, so they share the same final velocity. So that's 1.49. But then the initial velocity of the ball was 6 meters per second to the left. So that means the 6 meters here needs to be negative. So that's minus negative 6, like that, over change in time over a period of what? 0.1 second. Now we need to punch all this in our calculator. We have 0.4 bracket 1.49 plus 6, and then plus 6 because negative and negative is positive, divided by 0.1. And then we have a value of 29.96 newtons, right? So that becomes our F net. This is the net force that is experienced by the ball due to the buoy, right? So calculate the magnitude that the buoy exerts on the ball, right? Then we have that. So let's proceed to 9.3. Says write down the principle of conservation of linear momentum in width, still yet again. So you can see that the chances of having to see that formula is at about 99.9%, right? Then states that in an isolated system, the total linear momentum is conserved. Right. Then 9.4 says calculate the magnitude of the velocity v of the buoy before he catches the ball. So this is where we get to use the formula. Sum of momentum initial is equals to sum of momentum final. This is case number 2. The objects were moving separately, and then after collision, they moved as a unit. So that's M1 V1 plus M2 V2, and then finally they share the same velocity. Then what's your mass number 1? That's 50. You do not have the V there. You have mass number 2 of the ball, and then its velocity, remember, it's going to the left, so that's negative 6. And then mass 50 plus 0.4, and then VF, right? Now, all you need to, the VF we are given, it's 1.49. So here we put our 1.49. Then like that, this point you need to calculate. So leave this 50 VI here, and then we have 50 plus 0.4, multiply that by 1.49, and then we have 75.096. If we multiply this, that's 0.4 multiplied by negative 6, that's negative 2.4. If we transpose, that's plus 2.4. So we have 50 VI then we just add the 2, that's 77.496, divide both sides by 50. So our VI becomes 1.55 meters per second, rounded off to 2 decimal places, of course. Now, 9.5 says prove that this is an inelastic collision and show all the necessary calculations. So we know how to go about with that one. So first, EK initially, we have half mv initially square plus half mv initially square. Then this is half. The first object that we have is the ball together with the skateboard. That's 50 kg. Then our initial velocity is the one that we just calculated above, plus 1.55. Then square that. Plus half, that's 0.4. And then VI, that's negative 6 square. Let's calculate then. We have half 50 and then 1.55 square plus half 0.4, and then we have minus 6 square. That gives us a value of 67.26 joules. So that's EK initially. Now to calculate our sum of EK finally, that's half mv finally squared plus half mv finally squared. Now we have half, our mass still 50. The v finally we can see it's 1.49. Since they both share the same velocity, even for this one, it will be 1.49. Right, then square that. Now let's punch all that in our calculator. Half 50, we have 1.49 square plus half 0.4, 1.49, square that. Then we find a value of 55.95, rounded off to 2 decimal places. Now, looking at this, we can see that they are not equal. Now, what do we say? Therefore, the collision is inelastic. Why? Sum of EK initially is not equals to sum of EK final. Or you can just say sum of EK initially is greater than sum of EK final. Right. So that's how you were supposed to solve all this. So I believe we have tackled every question. So I just said we were just going to do a few, but then with the power vested on me by the Lord, I was able to do all these questions. So please hit the thumbs up button if you have enjoyed the lesson and you have found it helpful. Hopefully, having to do all these 9 questions along with me, you would have been able to pick up the trend and then just be able to grasp what it is expected of you when it comes to this topic. So just continue practicing. Any more materials that you can find, just keep on practicing. Please subscribe if you're watching the video and you haven't subscribed. And most importantly, share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.